Welcome. In a previous video, we looked at this example for filling in the missing limits and boundaries of this frequency distribution for continuous numerical data. In this quick example, we will look at how we can graph this distribution in Geogebra. We'll make a histogram, and in a previous video, I went into more detail about how to use the histogram feature of Geogebra, but basically what we need to do here is figure out the class boundaries. And we did that in the previous video. The class boundaries would be where the starting point and ending point of each of our values are, or each of our classes rather. So if we look here, the class boundaries are lining up with where each of our bars in our histogram begin and end. And if you remember, the middle value, the class mark, is the value that we use for each of these graphs. So 68, 75, 82, 89, 76, and 103. So those would all be the class marks, and those would be the values that we would use to predict. In Geogebra, it will be just as simple as opening up Geogebra. Let me do that real quick. Now that I have my split screen all set, we can do this quickly. I'll use the on-screen keyboard to start. If you're using a cell phone or an iPad, you'll have to go to ABC, start typing in histogram. You can then select the histogram from the drop-down menu. We need to use the curly brackets, which are in the function f of x screen. So open up the curly brackets, and we'll go back to the numerals, 57.5. comma, because again, 57.5 is the lower class boundary. The next class boundary is 64.5. We do not need to repeat this, even though the 64.5 gets used for both, because that is where the two classes meet. That will be where the bars meet. And I'm going to stop using my mouse so I can do this a little bit more expediently. 92.5, 99.5, 106.5. In the previous video, I talked about this with the class boundaries. We always need to go beyond our class limits to include the extra values to the left and to the right of them. All right, so after we have the class boundaries installed, and this is what the Geogebra function will show you, is that we have the list of class boundaries done, and now where my cursor is, it's where the list of heights are. The list of heights would also be the frequencies. We need to use the curly brackets. Again, it's in the function or f of x screen. Back to the numbers, we would get those. We're just going to enter in the frequency here. So 1, 6, 10, 14, 12, 5, 2. We'll hit enter, and we're done. But wait, where's the graph? It's hard to see the graph. The reason for this is, so our data values start at 50s and go up to 100. So we need to actually move our graph so it will show those values. All right, so let's do this an easier way. If we go to the settings gear and hit open settings, we want our minimum x value to be, well, let's say 50. Our maximum x value to be 110. Our minimum y value will make -1. Our maximum y value will make, it goes up to 14 for the maximum frequency. Let's make it 18. The y-axis and the x-axis, we'll count the x-axis by 5. We'll count the y-axis by 2. Oh, that's not what I wanted to change. I changed the wrong thing. 50 to 110. Oh, okay, that should show everything we need to, though. I think I was thinking of this one. Or we can change the units. Anyway, from here, we can move the graph a little bit. Also, it's really hard to show this on video, so I can't really show it, but if you pinch to zoom left, you can zoom in along the horizontal. If you pinch to zoom up and down, you can kind of focus in a bunch of different ways as well. But that's how we can change this. Again, touchscreen is really hard to show that, so I wanted to show the settings here as well. Here is our histogram for this continuous numerical data. And again, we can change the frequencies to make this a relative frequency, or we can change the frequency to make it cumulative frequencies. But no matter what, this is how we would make a histogram using the class boundaries. Thanks for watching.